And by continue on, I mean I'm going to start talking. We can introduce another conversion factor. These conversion factors can relate two units or two different things to each other. So what we're looking at is a percent, ultimately like grades. Okay, so what we're going to do is convert into a more manageable scale, and that's out of 100. So when we're looking at a percent, it's effectively the parts out of 100. So if you got an A in the class, minimally you had 90 parts out of 100 satisfied, okay, which we could then convert 90 divided by 100. We get into a decimal form, 0.9, and multiply it now by 100, and we get 90%. Okay? So these percents allow us to convert between those two quantities, one quantity versus the total possible, or our total sample. I'm kind of irritated that your textbook didn't discuss one important aspect of this. When you look at percents, what are your units? To go through and do this percent, we're looking at canceling our units, okay, which becomes a bit problematic. So if someone says, oh, that solution is 90% hydrochloric acid, what do they actually mean? Do they mean it's 90% by mass hydrochloric acid? Do they mean it's 90% by volume? You get different results depending on what you're specifying. So when you see a percent, you should also see this by mass or by volume. I believe the standard is by mass. So given a question, and we're asking for a percent, or you're going to use percents, we're talking about by mass, which means our one quantity would be in units of, what's our mass unit? Grams or kilograms, over our total sample, which would then be in the same unit, grams or kilograms. Okay? So if we take a look at an example here, if we take a look at bronze as an alloy of copper and tin, a sample of bronze contains 79.2 grams of copper and 10.8 grams of tin. What is the percent copper by mass in bronze? Okay? So what we're trying to do is come up with our problem. So we can start with our percent needs to equal the mass of our copper in the total mass. Okay? It's the part divided by the whole. So what's our mass of copper? That number is usually pretty easy to figure out. It's almost always given to you. So 79.2 grams of copper. What's our total mass? Crap, does it really add up to 100? It's going to be 79.2 plus 10.8 grams in total. Okay. We then go through and do our math, and we'd get our percent in this case, which should come out to be, assuming that little number in the lower right-hand corner was actually correct, 88%. There's a problem with that number. Sig figs. How many sig figs do we need to have in our final answer? We're going to have 3. When we add these two numbers, our least accurate decimal place is our tens place, so we don't have to stress about that. When we do that addition, it's up at 90. Whoa, come back here. Was it 90? So it would be 90.0 grams, 3 sig figs. What do we have up here? Again, 3 sig figs. When we do the division now, we go based on the least number of sig figs. Our least number is 3. Our answer gets reported to 3 sig figs. So it would be 88 point whatever that number is. I didn't actually calculate it apparently. Okay? Questions about that? So we can use these percents as yet another unit conversion. It allows us to convert between different potential units. So you might see different problems come around. The other option how much tin is in 100 grams of bronze? Now, that one's a little bit trickier. That's going to require a couple different things. To figure that out, we need to know how much tin is in a pure sample of our bronze. To do that, we need this conversion factor, our mass percent of tin in our alloy. So what we would have to do is first solve for that. So our tin, our percent tin, is 10.8 grams in 90 grams of our alloy. Okay. We want to know how much tin is in 100 grams of bronze. What can we do? Okay, what's our answer need to be? Grams of tin. If we take a look at our conversion, do we have grams of tin? Can we relate that to something else? Yeah. Where should our grams of tin show up? Numerator, denominator. Where do we want it to get our final answer? Numerator. Hey, that's nice. It's already drawn out for us. What's the problem? We have grams of tin per grams of alloy. We need to get rid of the alloy unit. Do we have some more information that allows us to cancel that alloy unit? What was our alloy?
90.
Our alloy is also known as, what's the first sentence say? Bronze is alloy. What does that mean? We've got 100 grams of our alloy over 1 again. What happens with our units? Cancels, and what do we get for our answer? Our grams of tin. Okay? So the percent is just another way to arrange the same kind of idea, the concept of these different units. We tend to give it a new name, or we give it the name of percents, but it's the same general idea. You're now comparing two things within an overall whole. Okay? Questions about your percents? How many sig figs should your final answer have in this one? You can tell how much I've done sig figs. So our percent deal gives us 3 sig figs, yes? What does the next one have? 1 sig fig, which means our answer has only 1 sig fig. Okay. How would we fix that, or how would I fix that on an exam? Really, really simple. Instead of giving you 100 grams, I would give you 100 decimal point grams, or 101. There we go. Now you got 3 sig figs. Okay. So watch out for those trailing zeros. Okay. I will try my best to make sure that you don't get trailing zero issues, because those look suspiciously like sig figs. Until you have that decimal point, those zeros are not significant. You cannot use them to calculate the sig figs in your answer. Okay, so watch out for that. Was you? Okay, Lane?
That one is also exact.
It's a measurement.
From the
Yep, it's given to you. Yeah, the 100 grams is definitely a measurement. Okay? I know you didn't like that.
Yeah.
Okay.
I had the same thought.
Okay? The only time you can assume exact is when you're doing the exact conversions. So metric to metric, I think that's it. And exact numbers, a count of them. A number of things, not a number of masses. That doesn't count.
12 inches in a foot, that's not exact.
That's within a unit. So within a unit system, those are exact. So English in English is exact. And metric within metric is exact.
units and metric together are
Not exact. Okay?
So if it was 1,000 meters or 1 kilometer, that's exact.
That's exact. It's within the unit. Okay, I definitely ran out of time on that. So